the area of a square? The side square. Now the side is going to depend on x, huh? Now I just need to know how is the side changing with respect to x. So that comes from the envelope. That comes from the dimension function. Right here. So we go from 0 to 7. What is it? 6 square root x. Here. And here. Negative 6 square root x. And then you start putting your squares in here. What is the length of one side? Well, you have to go from here to here. What is this distance?
2 times function.
What is it? What's this distance from here? Well, what's this? 6 square root x. What's this?
6 square root negative.
So what's this distance?
12.
S of x is 12 square root x. What's the radius when at 0? Sorry, what's the side length at 0? 0. What's the side length at 7? 12 square root 7. So I can put that here. What is it? 12 square root x squared. X. What is 12 square root x squared?
144x.
144x. And now it's a definite integral. We'll have to do that one. You have to read the question. When you have these situations, you want to have to read the question. What is your area formula? The first begin with what is the shape? Circle, pi r squared. Square, side squared. Triangle, half base times perpendicular height. Then you will have to say, well, how is the base and the height changing? How is the side changing? How is the radius changing? That will come from the envelope. Or the dimension function. Here, you can try this one. The solid lies between planes perpendicular to the x-axis at -1 and 1. The cross sections perpendicular to the x-axis are semicircles. So you need the dimensions of a semicircle. Well, the diameter or radius. And it tells you how the diameter is changing. From y equals -√1 minus x squared to y equals √1 minus x squared. Find the volume of that thing. First of all, you integrate from -1 to 1, correct? Area is a function of x dx. You need to tell me the area function. What's the area of a semicircle? Half pi r. We all agree we want this. 1 to negative 1 half pi r squared dx. But r is what? A function of x. You will take that function of x, square it. Anybody know what r of x is in this case? Envelope function. Here they are. So here's what's going on. We got the envelope. And here's the bottom one. And when you slice it, you are seeing a semicircle. You see the semicircle is quite big here. And the semicircle is even bigger here. The semicircle is not so big here. It's hard to visualize. What you have is some strange looking envelope function. So you semicircles changing. Semicircle changing. But the envelope is giving us the envelope is telling us the envelope is telling us the diameter as a function of x. What is this function here, Ms. Yasmina? And this one is the negative one, huh? So what is the diameter? What is the diameter?
Top minus the bottom.
Who said that? What is the top minus the bottom? That minus that, huh? This is x, you would be here.
That would be the diameter.
And this was x, this would be a diameter. This was x, this would be a diameter. That minus that, which is a function of x. That minus that is twice that. What's my radius?
Half of that.
Half of that. That's coming here. Huh? Aha. That's coming here. Counts 1 to negative 1, 1/2 pi. What? What's coming in here?
Root of 1/9.
And who knows how to find the antiderivative of that? Well, what's
Put it
this?
in there.
What's the square root of 1 minus x squared squared? 1 minus x squared. So now it's just as simple. If you want, like Miss Christina, you can take this half out. Yeah, fine. That's a simple antiderivative. That is a simple antiderivative. I'll leave it to Mr. Bogey for you to complete it all. Mr.
It's supposed to be 2.
Where's 2?
Right this much road.
Here? Yeah, but I want the
No.
radius.
Oh, radius, okay,
Ah.
okay.
What's the area of a semicircle?
Half pi.
Half pi r squared. So I have to find the radius as a function of x. That will leave the volume problem alone now. Let us move to the next problem. The length problem. Again, definite integral. I'm going to set up a definite integral. I'm going to set up a definite integral. The length problem. You want to find the length of something. Not an easy problem. This is an easy problem. Everyone knows how to find the length of that thing, huh? And some people know how to find the length of that thing too. Other people know how to find the length of that. What's the length of that thing?
It's right this circle.
Quite difficult. Quite difficult.